Good day, students. Today I want us to have a pen to paper argument on this paper that was written a few hours ago by matric learners of class of 2022. I think this paper repurposed their future due to nerve-wracking in the exam room. And I must be honest with you guys, the guys who said this paper tried every trick in the book to trick students on the basis of a certain norms and standards. Let's check what you guys have here. They are saying that question 5, given that the square root of 13 sine x plus 3 is equal to 0, where x is primarily the acute angle in between 0 and 90 degrees exclusive. Let's pen it down. So I'm going to have question 5. Let's check it. What are we having there? That is question 5.1. You are having the square root of 13 sine x and then a plus positive 3 there is equal to 0. And then where x is basically the acute angle, and those angles are primarily exclusive of 0 and 90 degrees. Think about it. We are going to really play with the situation to say that sine x is equals to negative 3 divided by the square root of 13. Think about it, Our x should be in the first quadrant. That means this situation must be positive because of the acute angle. So when x is negative, you are basically saying where is sine negative? So sine is negative where? In the third quadrant and the fourth quadrant. All right. So in the first quadrant, it's primarily positive, which is going to give you the acute angle, what they are looking for, or it's going to give you obtuse angle. But what you have here is primarily going to give you a reflex angle and a revolutionary angle, because that is where sine is negative. So I'm going to play some bit of maths here to say that if I square both sides, this really becomes a sine squared of x is equals to 9 divided by 13 if you try to square both sides. Try to resolve sine x again and tell me what you get. Check now. You are going to get sine x is equals to positive 3 divided by square root of 13, or sine x is going to equals to, this would be negative 3 divided by square root of 13. Think about it. This one is the one which you saw it from the first go. So you won't really use this one because it's primarily going to give you a reflex angle and the revolutionary angle. You want the acute angle, which is this one. Remember, but this one is going to have acute and obtuse because that is where sine is positive. So I'm going to take the one in the first quadrant to really play about it because acute there is in the first quadrant. So let's try to redraw it again in the first quadrant. We know how to deal with this situation. We are definitely going to have something which behaves like this. It's primarily a triangle, in the first quadrant. Let me try to put that in the origin, and that should really be 90 degrees. Try to put a 90 degrees in there so that you can use your Pythagoras theorem. And that is opposite of hypotenuse. That means you're going to get 3 there and the square root of 13. How do you find x? So x is going to be equals to the square root of the hypotenuse, which is, you square the hypotenuse. So it's 13 minus the opposite, which is 9. And as a result, you're going to get 4. So therefore, x is going to be equals to 2. It's positive, just right there. Now you can try to answer the question. What are they saying there? They are saying that 5.1 determine the value of, so we are looking for the values of sine of x, sine of 360 plus x. That is in the first quadrant. 5.1.1 sine of 360 degrees minus x, which is primarily, it's plus x, by the way. That is a periodic identity. It becomes a positive sine x. As a result, you are definitely going to have that situation, which is going to give you 3 divided by 13. You can try to rationalize it Let me check what you're going to get if you rationalize it. So some of you may write it in this way. That is 3 square root of 13 divided by 13. Is still correct for that. And then 5.1.2. What are they looking for? Tan x, and the other one is cos of 180 plus x. So that should really be very easy. Now we are looking for the tan x, which is primarily the opposite. So that is opposite over adjacent. So what is our opposite? Remember, you're going to get your x there being acute. So I'm going to put it there. That is x. Let me put it here. That is x there. So the opposite is 3 there over 2. All right. So that should really give you 2 over 3. The last one, that is 5.1.3. That is a cos of 180 degrees, and then a plus x. That is in the third quadrant, where cos is negative. I'm going to get a negative cos of x there. So what is cos? Cos is primarily the adjacent of hypotenuse, which is primarily the negative of the adjacent over the hypotenuse. So it's going to give you minus 2 there over root 13. So you get negative, already you put the negative, so it's 2 over the square root of 13. You can say, or I'm trying to rationalize that for you. Let me really check that. This is going to be, or negative 2, the square root of 13 over 13 is basically the same stuff. This is how far you can go with the first 3 questions. Now let's check what are they looking for the next question. Determine the value. So we're looking for the value. That means it's a number of the following expression without using calculator. That is cos of 90 degrees plus theta over sine of theta minus 180 degrees plus 3 sine of negative theta. That is 5.2 I mean to say. So we have 5.2. Let's check what are you guys having. Let me put my quotient line here. I'm going to get cos of 90 degrees plus theta. That is sine of theta minus 180 degrees. Let me say plus now 3 sine of negative theta. Let's confirm if it's what we are given here. Cos of 90 degrees plus theta over sine of theta minus 180 degrees plus 3 sine negative theta. So we are going to use identities here to say that we are looking for the value of this stuff. So if you look at it nicely, rather with a bird's eye view, you will see that this one, it's in the second quadrant. It's basically called the co-functions identity, where you get a negative sine of theta. And this situation is primarily a negative angle. I hope you know how to deal with that. You know how to deal with that. That should then give you a negative of sine of x. It's a negative angle. And then this one is a fundamental identity. So this negative goes outside. You are not going to get negative 3. And then sine of theta. I don't know why I'm writing x. This should be theta. We are dealing with theta here. That is the fundamental identity, and that is your co-functions identity, and that is negative angles. So that is the main goal there. And then you get negative sine of theta divided by, and then in your denominator, you have some like terms there, and that is negative 4 sine of theta. So what is the value that they are looking for? They are looking for this, can cancel with that. So you're primarily left with negative 1 over negative 4, which is primarily 1 over 4. That is the value that they are looking for. That was really easy. Where do you get the marks here? Let me check how many marks. that was 5 marks. If you are able to change the identities, that's where they are going to give you the marks. I think it's primarily that one, and that one. It makes that to be 3 marks. And then to simplify that stuff there, and then and also to get your final answer, that makes that to be 5 marks. Well, let's check the next question very quickly. 5.3, determine the general solution of the following equation, that is cos x plus 2x into 3 sine 2x minus 1 is equal to 0. Let's see how far we can go with this one. That is 5.3. We want to find the general solution. This is going to be cos x and then a plus 2 sine x into, that is 3 sine of, that was a 2x, and then a minus 1 is equal to 0. Let's just confirm that. That is a cos x plus 2 sine x into 3 sine 2x minus 1 is equal to 0. So we want to find the general solution of this situation. We are going to say to ourselves, therefore, each factors must be 0. We are primarily going to apply paper 1 mathematics, which is really very easy. Sine of 2x there, that is a 2x minus 1 must be 0. If you try to really do it nicely, you are definitely going to get a cos of x is equals to negative 2 of sine x, or 3 sine of 2x is equals to 1. And as a result, you need to convert this situation into single trig ratio, and that is going to be the tangent of x is equals to negative 1 over 2, or sine of 2x is equals to 1/3. So you want to find the general solution of this one. That should be very easy. Think about it in this way, that you need to get the reference angle of that. So for tangent, you just need only one answer, unlike cos and the sine. Here you just need to give them the reference angle, and that is going to be the arctangent of 1 over 2, which is going to give you what now? Let's check. If you type that, that is the arctangent of 0.5. That gives me 26,57. Therefore, the general solution is going to be x is equals to, you check where tangent is negative. So it's negative in the third quadrant, in the second quadrant, in the fourth quadrant. So you can just write one of the two, but don't write all of them. So I'm gonna choose the one in the first quadrant, which is primarily 180 minus this number here. That is 26,57 in there. You say plus the period of the tangent. That is primarily your 180 degrees k, where k is an element of integers. Therefore, the general solution is going to be, let me type it, I'm getting 153, comma, this should be 43, 43 degrees plus k times 180 degrees, where k is an element of integers, where k is an element of integers. This is how far I can go with the first one. Let me try to really put everything together so that we don't really have a mediocre work. And then just like that. That's how you would go about the tangent general solution. Now you need to get the other one. So the other one, you're still going to get your reference angle. The reference angle is going to be the arc sine of 1/3. And let's check what you get then. The arc sine of 1/3, I'm getting 19,47. That is 19,47 in my calculator. So you're going to check where is sine positive. Sine is positive in two situations, the first quadrant and the second quadrant. So therefore, you're going to get x is equals to, by the way, you have 2x here. So behave, you're going to say this is 2x is equals to the reference angle in the first quadrant, and that is 19,47 plus 360 degrees for the period, where k is an element of integer. Therefore, x is going to be equals to, you divide this by 2, you get 9,74. You get a 9,74 in here. That is in degrees. These are in degrees situations. These are in degrees. Don't forget to write your degrees there. You are measuring this stuff in degrees. Well, you're going to have a plus of what now? You divide this by 2. That is 180 degrees k, where k is an element of integers. So you're going to write or now. Where is sign positive? Sign is positive in the second quadrant. So you're going to get a 2x is equals to 180 minus the reference angle, and that is a 19,47 plus 360 degrees, and then where k is an element of integers, therefore 2x is equals to that. Let me say to myself now, if I subtract that, I'm going to say 180 minus 19,47. It's really giving me 160,53 degrees plus 360 degrees there. K, where k is an element of integers. Therefore, the final answer will be x is equals to, you divide by 2. You divide that by 2, that is 160,53. Divide by 2, we get 80, so we get 80, something there. Let me just write it. That is 80, 26. I think it's 2,7 if you round it off. Let me do it in this way. 180 minus the arc sine of 1/3. I need to divide this by 2. If I don't round it off, it's going to give me 2,6 degrees plus 180 degrees k, where k is an element of integer. So this is how far you will go with the general solution of this problem. Yeah, that was how many marks was this situation? This was 6 marks. Okay, so that is really easy. Let's check the next question. What are they saying? They are saying that given the identity, that is a cos of x plus y multiplied by cos of x minus y, which is equals to 1 minus a sine squared of x minus sine squared of y, then prove the identity in 5.4.1. So, okay, that is a small water. You get a 5.4. You are given the identity, which is cos of x plus y multiplied by a cos of x minus y. Let me just put minus y there, is equals to 1 minus sine squared of x minus sine squared of y. And then 5.4.1, they say prove this situation. So I'm going to be proving it from the left. I may need to really copy it. This is what I'm having. Now, if I'm to prove from the left, because that is where it is complex, so I'm going to really put it here and expand this. If I expand it, I'm going to use compound angle identities, and that really becomes a cos of x and then a cos of y minus a sine of x multiplied by a sine of y there. And then you close that and expand this situation. It's primarily going to be the same stuff here. What will change is the sign of the middle one. That really becomes positive, and you close that. Very easy, right? So minus there. Check something here. You got a negative and a positive there of the same term. That makes it to be a difference of two squares. So I'm going to get cos squared of x multiplied by a cos squared of y minus a sine squared of sine squared of what now? Of x multiplied by a sine squared of y. This is how far you can go with it. But check something. Everything is in terms of y. I mean, in terms of sine x and y on the left side. So I'm going to remove the cos one. So let's remove the cos situation here. How do you then do that? What is a cos squared of x? That is equivalent to 1 minus sine squared of x multiplied by what is a cos squared of y? That is basically the same situation just right here. But what changes there is primarily your x. It really becomes y, and you still have your term just right here. That should really be very easy, right? Therefore, if you multiply everything there, you get a 1, and then that and that is a negative of sine squared of y. That and that, it's a negative of sine squared of x. Then the last two terms becomes positive sine squared of x multiplied by sine of squared of y. You still have your term just right here. I want you guys to see something. That term there, that term, you know, and primarily this term, I may really take even that sign. Those two situations are going to undo each other. So this one then means that you are going to cancel them, and you will be left with a 1 minus a sine squared of x minus a sine squared of y, which is primarily what you were proving from the right to the left, and you may say that which is the right hand side. Remember, you were proving from the left side, so you must show that that is the right hand side. What you are getting, what is the next question primarily? They are saying that hence determine the value of 1 minus a sine squared of 45 degrees minus a sine squared of 15. That is a 15 situation, eh? Okay, that is a 15. So this is 5.4.1. So I'm going to say this is 5.4.2. You want to determine the value of 1 minus a sine squared of x there. No. It's 45 degrees minus a sine of squared of this situation of what now? That is 15 degrees. Let me confirm. It's important to confirm that is 1 minus a sine squared of 45 and minus a sine squared of 15. That is degrees now, 3 marks. So what I will do is, because I have proven that that's what they said, hence is because you want to use what you have proved. So this basically this situation, it resembles that particular identity which you proved that it is equals to cos of the sum of the angle, and then you also multiply by, you subtract the angle. So this will then mean that you are going to get a cos of the angle, you add them. All right, that is 45 degrees plus 15 degrees. But you need to multiply it by cos of, that was x minus y. Check that in this order. That was x minus y. So that is, your x in this case is 45. That is 45 degrees minus 15 degrees. As a result, I'm too lazy to think about that. And then 15, that is really going to give you 60. So this is a cos of 60 degrees multiplied by cos of, let's really subtract that. You get 30, even you get 30 degrees. So this really makes your life easy. What is cos 60 now? Just get a half there. Into cos 30, I think cos 30 should be root 3 over 2, right? The way I know it should be that. And wow, this is a beautiful stuff. You get root 3 divided by 4. This should then suffice to 5.4. All right, this is how I'll go about trigonometry. Let's check the next question. That is 5.5. They give you consider the trigonometric expression, and that is 16 sine x cos cubed x minus 8 sine x cos x. Rewrite the expression as a single trigonometric ratio. Okay, so this should be very easy to all students. Okay, let me put it here. That is 5.5. What are you given? They give you 16 and then a sine x multiplied by a cos cubed of x minus 8 sine of x cos of x. They are saying to you 5.1.1, rewrite this one as a single trigonometric ratio. So I'm going to copy it again and start working on it. Think about it. What is your common factor here? That is 8 sine x cos x. So let's take it out. We are going to take 8 sine x and cos x. Now we'll be left with 2 cos squared of x minus 1. Think about it. What is this situation? That is a cos 2x. It's a double angle of a cosine, of a cos trig ratio, right? And what is this situation? That is primarily the same as saying that this is 4 into 2 sine x cos x into this one is primarily going to be a cos of 2x in there, and that should be 4 into, what is that now? That should really be sine of 2x times cos of 2x. We want to express it as a single trig ratio. So what is 4? 4 is primarily like 2 times 2, eh? And then multiply by, let me just do this, multiply by sine of 2x multiplied by a cos of 2x. And what is this situation? It really resembles the double angle of sine. That means that you are going to get, that should be 2 sine of 2 multiplied by that angle, and that should suffice to 4x. That's how far I can go as a single trig ratio for this particular problem. Extremely easy. I've just applied the basic maths. What are they saying now as a last question, I guess? For which value of x in the interval 0 to 90 inclusive will this expression have its maximum value? So they're looking for the value of x for which this graph is going to have the minimum. This is the minimum. Will have its minimum value. Okay. So the minimum value of it, my goodness. So what is 5 point, okay? This is 5.5.1, 5.2. We want to have the minimum, what is the value of x for which this guy here will have a minimum value. So think about it, but for value of x, So think about it in functions. Like, let me say, let f of x equals to 2 sine of 4x. I want to try to sketch it because I'm going to see where this graph is going to have a minimum value. But they're saying that x is in basically the angle is between 0 and 90 inclusive. So let's try to sketch this graph. How many marks primarily? This will be easy. It's 1 mark. Okay. So this is 1 mark. What I will do if I were you, I will try to sketch this graph from the positive side of it. From the positive situation of it. Okay, the maximum value here will be 2, but this 4 is going to really reduce your angle. I mean your period. The effect of that 4 is primarily the period. What I will then do here, it's very basic. That is 1 and then a 2 there. 1 and then by the way, you don't have to do this. I'm doing this for those of you who want to get the clarity as to what is happening here. If you want to sketch this graph from this space, so let me say that I'm going to have that and that one. Let's have 45 degrees and 90 degrees. So because it's a sine graph, it must be defined in this situation. So you are definitely going to have this situation like that. I guess the minimum they're talking about, it will really be in that space. It will really be in that space. So I'm looking for the x value here, for which that will be the case. Okay, so let's think about it in this way, guys. So here it's going to be 2,5 degrees. Let me check the other one. So I'm trying to get what is the x value at this point. So I won't really waste time. I will imagine that you guys know it. So that is negative, no, it's positive, I meant to say, 67.5 degrees. How do you do that? Say 90 plus 45, we divide this by 2, should be able to give you 67.5. So what, let me read the question. I don't want to answer it wrongly. For which value of x in the interval will this expression have its minimum value? So think about it. The minimum value here is at -2, but we are looking for the x value at the minimum value. So that is the value there. That is the value there. Yeah. That is the value. So you will then say to ourselves, therefore, x is going to be equals to, this will be 67.5 degrees. They just want the answer. I don't know how you're going to really get that answer. That answer there. And let's check something here now. How you're going to go about it. I'm trying to check some alternative, because this is mathematics, so there should be a myriad of ways to do it. Let me look at it in this way. Let me check something. That is 270. It's positive. So that should be 360 minus 90. And then divide this by 4. Okay, I'm thinking about it, guys. I want to verify if what I'm doing is correct. So, but I trust my capacity. It's correct. Let's say, or for those of you who love maths like myself, how will you approach this question? And again, I'm saying that this is f at x is equals to, what am I doing? f at x is equals to 2 sine of 4x. Where is this graph going to have the minimum, the value of x? So the minimum, you can use calculus again. So this is going to be the first derivative, that must be 0. That's where you're going to have the minimum there and the maximum. So think about it. The prime of that is going to be 8. And then what now? Cos of 4x is equals to 0. Therefore, cos of 4x is going to be equals to 0. Think about it. Where is cos positive? So cos is positive in the first quadrant, and the second and the fourth quadrant. That's where this is positive. But here it's primarily the first. It's primarily the reference angle, and then here is 360 degrees minus the reference angle theta. So this means that you're going to say to yourself that let's get the reference angle. The reference angle is going to be arc cos of 0 degrees, which is really going to give you what now? That is going to give you arc cos of 0. I think it's 90, you know. That is the pole. It's some way. That's where the graph really passes through. So that is 0 there, you know. So, well, we get a 0 there for that stuff. This means that you're going to say to yourself that 4x is equals to 90 degrees, you know, or where is this guy? Where is cos positive? It's positive here. That means you're going to get a 4x is equals to 360 degrees minus the reference angle, which is this one, where k is an element of integers. So you're going to get x is equals to, let's do it. You're going to get 90 divided by 4. 90 divided this by 4, that is 45 over 2, which is the same as 22,5. I'm going to write or. Now I'm going to get 4x is equals to 90. 360, that is going to give you 270. 270 degrees, therefore x is equals to 270 divided by 4. That is 135 over 2, which is primarily going to be 67,5. So this is where the graph is going to have the maximum and the minimum. It means the maximum it's at x is equals to 22,5. The minimum is this one. Let's check it. The maximum it's basically the point which we have discovered, and then the minimum is this one, because this graph has a minimum value at -2, you know. So the correct x value primarily here, you'll say therefore x is equals to 67,5 if you want to use the last method, but I prefer that you use the first method. And thank you very much for sticking and staying with me here. Watch the next videos for other questions like Euclidean and analytical geometry, which will be my next video, analytical geometry, the second one. Thank you.